So last time we learned 7 formulas. Okay, 7 formulas. Let's take a look. First one. The second one. EA to the power T equals 1 over S. E cosine KT. F sine H K. G. Okay. So we learned the 7 Laplace transform for this basic function. Okay. Now let's take a look at examples. I'm gonna give you guys this example. Let you guys try it. The first example is here. The easiest one. Okay, the easiest one. How about the Laplace transform of this guy? Try it by yourself. I give you guys 1 minute. Okay. Okay, I'm gonna write down the answer on board. Let's take a look. So for this example, we can write down like that, right? We'll follow the sum rule, right? We're gonna split this function to two functions. One plus Laplace transform 15t. And here we have 15, right? We can always put the coefficient 15, right? Or the constant out of the Laplace transform, because the Laplace transform is about the integral. Integral, when you do the integral, that's a multiplication with a constant. So you always can put the constant out of the Laplace transform, okay? And this guy is 1 over s. 15t is 1, because here n is 1, right? Formula 2 is 1 factorial. So 1 plus 1, right? 1 over s. That's it. That's it. Okay. Now let's take a look the second one. Laplace transform try this one for me. Okay. Okay, I'm gonna write down the answer on board. So let's take a look. Right? And then pull this constant out of the Laplace transform. Um, and then we have use the formula for the first one, formula C, right? C. So A is 6. And this one is formula K is 2, right? And again, we can see we can see. So that's the answer. Okay. Now let's take a look at the last example. Okay, try this one for me. Okay, let me write down the answer on board. Let's take a look. So for this guy, we have 3 terms. So basically, we're gonna spread these 3 terms, right? So we have what? Right? We have this guy. And again, we're gonna get 10. We have what? We have A is -3. Here's a t. So we're gonna have 1 factorial 8 1 over s. And we can simplify. We're gonna get 10 s power 3 by s squared 8 over s. So that's the Laplace transform. Okay, Laplace transform. Okay, we already finished all of them. And today we're gonna move to the inverse transform. Inverse transform. Okay. For the inverse transform, we use the symbol like that. Okay, let's take a look. Transform. We write down like that. Okay. For the inverse transform, we use the Laplace -1 to the power -1. That is inverse transforms. Okay. Now let me write down the formula for you guys. For the inverse, basically is the reverse process of the Laplace transform. For example, here Laplace transform of 1 equals 1 of s. The inverse transform gonna be what? Reverse. Okay. Inverse transform 1 over s equals 1. Okay. Here from 1 to 1 over s. Now inverse gonna be 1 over s to 1. 1 over s to 1. Okay. B inverse factorial divided by s n plus 1 equals t to the power n. Okay. Here the same thing. Because Laplace transform from Tn to n factorial divided by Sn plus 1. Now, should from left n factorial over s to the power n plus 1 to t to the power n. Right? Right. Similar for the other formula. Okay, I just write down the other formula here. Okay, so very similar to the other formula, just do the reverse process. Okay, so that's all this formula. Just reverse progress of the previous formula, right? We can compare it. Exactly the same thing. Exactly the same thing, just reverse it. That's the inverse transform. Now let's take a look, one example. How to use this formula to calculate the inverse transforms. Okay, so first example, how to calculate the 1 over s to the power 4. Okay, how to calculate the inverse transform of 1 over s to the power 4. How to transform it? Now, the key part is for this formula is here, right? We need to find the n. What is n? N is n plus 1 equals 5, right? N plus 1 equals 5. So n equals 4, right? N equals 4. Because n plus 1 equals 5, you're going to get n equals 4. Okay, so we need to compare this formula. So in the numerator, supposed to be n factorial, right? N factorial. So we can write down like that. N is 4, okay? S to the power 5. Since we put 4 factorial in the numerator, then we're gonna divide by 4 factorial. Otherwise, couldn't equal to original one, right? We multiply 4 factorial, then divide by 4 factorial. Right? You can see it. So now, okay, we can put this constant out of this inverse transform. Okay, we can always put a factorial or put a constant out of this inverse transform. Okay, we got this guy. And this guy equals what? Follow the formula. It's t to the power 4, right? 4. So we have 4 plus 3 plus 2 plus 1. T to the power 4. Follow the formula. And this guy equals 24. That's it. That's it. Okay. So the key part, you guys needed to find the n. What is n? Right, corresponding to this formula, we're gonna have equals 4. So since this formula requires the numerator should be n factorial, so it's 4 factorial. So if you put 4 factorial here, you need to divide by 4 factorial, right? You add 1, you're gonna you put a 4 factorial, you need to divide by 4 factorial. Okay, and then put this guy out of this Laplace inverse transform. And the whole thing is equals t to the power 4, right? And the coefficient is going to be 24. Now I'm going to give you guys one example. Later you guys try it by yourself, okay? For example, I put the 2 here to calculate this inverse transform, the inverse transform. Okay, let me write down the answer on board. Okay. So for this guy, of course, we're gonna use the formula B, right? So basically, you need to find what is n. N plus 1 equals 3. So n equals 2, right? 2. So basically, what are you gonna do? We need a 2 factorial, right? 2 factorial. And the numerator, we have 2 here, divided by 2 factorial. Right? Here is a little bit special. We put follow the previous example. We need a 2 factorial, 2 factorial divided by 2 factorial, and here we have 2. You just put a 2 here. Okay, put a 2 here. So basically, if we cancel out, we can still get the original one, right? So now here's a special because 2 factorial is 2 times 1, right? So we can cancel out this one can be actually cancel out, right? Cancel out. So is what is okay. Now what is this guy? Follow the formula. Is t to the power 2, right? T to the power 2. That's it. That's it. Now let's try another one. Laplace transform of 2 over s plus 3. So how to do the Laplace transform this guy? Basically, we're gonna use the formula C, right? Formula C. So try it by yourself. Okay, try it by yourself. Okay, let me write down the answer on board. Let me write down the answer on board. So for this guy, it's very clearly we need to find what is A, right? For this guy, it's a little bit tricky. S minus -3, right? Because S subtract A, right? So S subtract -3. Here's a plus, so we need to put a minus, right? So it should be a S subtract -3, right? And for the numerator, it should be 1. So we can write down like that, times 2. Right? For the numerator, it should be 1. Follow the formula like that. And of course, you can put right and pull this constant out of the inverse transform. And now you can use the formula e to the power negative 3t, because we know a equals negative 3, right? Go ahead, try this one for me. Okay, let me write down the answer on board. So for this guy, we can see the a is what? A is 5, right? Is 5. So we'll put the constant out of this guy. So we're gonna get this guy, right? Because a is 5. A is 5. 5, right? 5. So so a e to the power of at gonna be 5t, right? Now let's try the example. This guy. 1 over s squared plus 7. And for this guy, corresponding to this this formula, okay, this formula. And be careful, you need to find what is k, okay, what is k. Try it by yourself firstly. Okay, I'm gonna write down the answer on board. So for this guy, you need to be careful. If we use this formula, what is k? So very specifically, here should be k squared, right? So here's a 7. What are we gonna write? We're gonna write square root of 7 squared. Okay, so we know the k is square root of 7, not 7. Here's square, and the numerator should be square root of 7. Okay, you should put a square root of 7. That means we're gonna divide by square root of 7. Okay, square root of 7, and then pull out this constant. Right, and then we can write down the sine kt, right? Sine kt. That's it. Now I'm gonna give you guys an example. Let you guys try it. Okay, try it by yourself. Okay, let me write down the answer. Again, for this case, you can write down the let's write down the denominator is 3 square, right? 3 square. So k should be 3. Then you're gonna have 3 over 2. 2 over 3, because initially we have the 2, right? And then here 3 we divided by 3, right? Divided by 3. Then when you multiply together, we're gonna get the original one, right? 3 cancel out, we're still gonna get the original one. So 2 over 3 s squared 3 squared 2 over 3 sine kt, k is 3t. Okay, that's it. Example 7. let's try the last one, okay? Let's try the 5 times s, okay, divided by s squared plus 16. Try this one for me. Okay, now let me write down the answer on board. So for this case, in the numerator, we have s. That means we're gonna use the formula here, right? Yes. And still you need to be careful what is the k. K is 4, right? Times 5. We need to follow this formula, right? And the k is 4. So we can write down like that. And then 4 cosine kt 4t, right? 5 times cosine 4t. That's it. Now I'm gonna give you guys the last example. Okay, the last example. One over s squared minus 6. Okay, so here, let me write down the answer on board. For this guy, we need to use the formula here, right? Here. So the key part is still find out the k. K is square root of 6 square, right? The denominator is k square, so square root of 6. And for the numerator should be what? It's k. Right? You put the square root of 6, then divided by square root of 6. And we have what? And you're gonna get 1 over square root of 6 sine h square root of t. 6 or square root of 6t. Okay. Use the formula f, right? Formula f. You're gonna get sine h square root of 6t. Okay. That's it. That's it.